coming, everyone. Welcome to the May Coding Dojo. We have a special guest tonight, Mr. Hans-Henry Sandbeck and Florian Schlemeyer. I believe that I pronounce your name right. Okay. They came from München, from Munich in English, to present us the SimpleFX library for creating GUI applications. They will present us today as an introduction to our Coding Dojo. And after that, it will be a regular Coding Dojo. As usual, we will code anything that we want in a small group that we will form after the presentation. And any of you is free to try the SimpleFX for some kind of application, and guys will be happy to help you with that. So enjoy the evening.
Thank you. So, what is SimpleFX? It's a DSL which is supposed to make programming simpler. Very exciting mission, so to speak. SimpleFX is a Scala DSL which is very much utilizing the functionality of JavaFX. I don't know whether JavaFX is known to anyone. A little bit, right? Yeah. But Swing maybe. Swing is maybe known to you, even from Scala maybe. Yeah. And anybody who likes to use Swing?
No one does.
Okay. Yeah. No, JavaFX is the new Swing. Oracle, since 1 or 2 years, said JavaFX is the new UI library for desktops and Internet of Things. And meanwhile, also there are some community guys who have done some very good work to port it to mobiles. So JavaFX is running almost anywhere, and we have created a wrapper and some additional functionality on the top of JavaFX, and we have extended Scala to a DSL, which is generally being used not only for user interfaces, but especially for data binding in particular, which is of course very useful when you create user interfaces, but not only. So SimpleFX is started with as a wrapper for JavaFX and has developed beyond that, and is going to go to the backends, to the server pretty soon. And as I said, JavaFX is already running on a lot of platforms, but some of them are missing. So we have done some work which you will have a glance at today, which we think is relatively exciting for the Java and Scala community. To be more concrete, we are able to run Java or Scala applications in the browser without plugins. It's at a very early stage, so you will not be impressed by the samples that we show you, but I think in a couple of months we will be able to launch it, and then we basically have a product with which you can create user interfaces and some other things, but in particular user interfaces which runs basically anywhere. So it runs on, of course, all the desktops, because it's JVM based, but it runs on mobile, iOS and Android, and it runs, of course, on the most Internet of Things, on the Raspberry Pis and all those kind of cool stuff. But that's basically because it's Java, so it's not so very exciting. But we have been able to extend it now to the browser. So we'll come back to it. We'll show you some simple samples, and we will not be able to tell you exactly how we've done it. That we can do a little bit later, for reasons which we can tell you later. Maybe.
To say it yet, I've got at the moment a small problem to run the sample, so for the first moment I have to point to Jakob and Karel, which already have seen it, but I'm not sure if I can show it exactly at the presentation, but probably shortly after.
Okay, I will try to stretch it a little bit. We propagate a little bit of a new way of programming, a different way of programming from what you're used to. We focus very much on data binding, which is a very unprecise term. We like to call it expression binding because we have stretched that term pretty far. So you are able to create your own invariants, you are able to create programs which are very declarative, and the code becomes very concise. You will see that afterwards when you go into the source code, but before that, I'll just give you a little bit of background, also go into some of the syntax elements and so on. Right. Yeah. Yeah, thank you. But we'll go into the source code later on, so you can really see the extensions which we have made to Scala, basically. We have almost creating our own programming language, which you will see later on. Also using a lot of macros in Scala, so that we had some presentations earlier where when Scala developers said, well, that doesn't look like Scala at all, it looks a bit strange. So we'll come back to it. So it's very important for us to focus on the Vora paradigm, the write once, run anywhere, which has been a term for years in the Scala community, in the Java community, and I think the community has become a little bit disappointed, in particular because the browser technology, of course, is HTML5 is about to kill Java almost on the different client platforms. So we try to come up with some alternative there to classical technologies for the web. Okay, I will not talk too long. Before we start, I will come back to tell you a little bit about the background. So now we go into an application, a sample, which you can have a look at, which we will show on the surface, because it's using the touchscreen capability of JavaFX, which we have stretched a little bit and extended in SimpleFX. It has a small history.
Don't drop it, please.
No, I try to plug it in. It's a Beamer.
Anybody being a guitar player?
No one?
No? Okay. Because this application was actually presented, you can find it on the internet as well. It's on the YouTube and so on, from a prominent guy called James Weaver, who is working for Oracle. He has a long history in the JavaFX community, and we met him, and he asked us to convert his application, which he called Zen Guitar, into SimpleFX. Yeah. And that we did. And of course, the code was down to 20% of the original one. Partly because of Scala, partly because of SimpleFX. So, this one was built to show the 3D effects, capabilities of JavaFX.
I should have made the application so that it adapts to the resolution. And the Beamer should update.
If it's connected to the Beamer, duplicate this. Oh, it's not working. Sometimes.
No.
Okay, then turn it around.
Yes. That's more
Turn it around and
practical.
play the guitar and show them.
Just to,
Yeah.
I can
Sure.
put it on. So I think it's quite full proof that it's not the tablet. How it works.
PC.
You can touch on the different strings, and you can also put on them to the up and downs on the pulling, and you can pick your instruments. Or play with multiple fingers at once.
This is not how I do.
Play some Eric Clapton.
Yeah. Maybe it's more clever.
No. It's just a fun application, showing some 3D effects and using the media library. But it runs everywhere. That's unique about it. And if you go into the source code, which we maybe can do later on, you will see that the source code is very concise. It's not long. I think it has like 300 lines of code, the whole thing, which I think is not bad.
Someone switching to Chimbo.
I think when this one was presented for the first time by James Weaver, he was playing duet with a real bass player, and James Weaver played on this one, and the other guy played on the lead guitar. You can find it on the internet. Okay, here actually the presentation, we have a screenshot of the presentation. James Weaver is was one of the keynote speakers at the Java 1. And has anybody heard about ScalaFX? Also a little bit, yeah. Yeah, I think it was on the type-safe page for a while. That's an open source library which is also a wrapper around JavaFX, which was led by Steve Chin, who's there on the picture, on the slide. We met him also, so he also knows SimpleFX pretty well. But let me tell you a little bit of the background. Why did we do this? Why did we develop SimpleFX? My background is from the TV industry. I've been creating products for the TV industry for basically my whole life. So the last generation which we developed was a Java Swing application, which is now running at some TV stations around Europe and in Russia and so on. And as I wanted to create a new generation again of products, I definitely didn't want to use Swing again. So I started to look into different kind of technologies, like Adobe Air, like Silverlight. It was a year ago, that was the hype. So different rich internet application technologies, VIA technologies. So I came along JavaFX at that time, which was very hyped by some. Some had to do different Java 1, very cool demos. They showed it on the Google TV, they showed it on all kind of platforms, on the mobile. That was before Apple was a blocked Java application for the Apple Store, so it was also running on the iPhone. So it looked very promising, but some didn't really deliver well. So as Oracle took over, there was a kind of disappointment in the Java community about JavaFX. So Oracle made a decision. They rewrote the whole framework, the whole JavaFX framework, and created a standard Java library for it. And the JavaScript language was made open source, and today it's called Visage, also led by Steve Chin. And we took they had some nice elements, especially with data binding as well, which we have adopted into SimpleFX. So at that time I didn't know Scala, as I was looking for how to create some new framework for the new product platform. So then as we developed Scala, then we saw that it was possible to stretch the language a lot, so we could create a lot of those syntax elements and kind of feeling that we were looking for. So that we are pretty satisfied with now, how we have been able to do that with Scala. So, and of course we wanted to make Java also still being interesting on the client platform. So we made a lot of work to make it run in the browser, which you will see later. So yeah, this is an application which we will show you now, which is also an application which was originally written by an Oracle JavaFX guy called Jasper Pot, I'm sorry. And this was, I think, 30 pages of Java code, and we rewrote it in SimpleFX. It came down to 4 or 5 pages. So that was the relationship. That was Java 7, okay, so to be fair. But still, there's a huge difference in terms of expression, being able to express things in SimpleFX and Java in particular, but also in Scala. So, there it goes. Yeah, it's a very simple from the source code, which we could also take a look at. It's very simple. You have an image in background, and you can drag the different sliders and adjust the frequencies and so on. You just put some sliders upon an image, and we created a knob here based on 3 images, and relatively easy source code, but it looks pretty neat. And it basically plays a playlist, so you can go back and forth, go to the next. Yeah, it basically plays a playlist. You can also play from the internet. Okay, just to show you a little bit of what's easily doable with SimpleFX. Okay, that was the very short introduction to this. I think we will skip this web browser. It's not that extremely interesting. So we can go straight now into the source code. Maybe you can maybe we can. What do you think? Maybe we should make a small break to see whether you can fix this Java problem. What do you think? No?
Takes this road.
Yeah, it's really sad.
So it's unpredictable.
Yeah, it's really sad. Okay.
You want to see the code?
Yeah, then we go to the code. Okay,
Code
before we
is
go,
more interesting.
yeah, maybe we tell Florian he's not allowed to get any beer before he makes that run tonight. So let's do it this way then. So, let me tell you about some basic syntax elements in SimpleFX before we go into the source code, because then it's easier to read the source code afterwards. We have something which we have called bindables. Those are the SimpleFX properties. For instance, in JavaFX there are about 40 different properties. In SimpleFX there is one property. We call it bindable. And this one can adapt a lot of different data types, and it has a lot of functionality in it. And because we have used the implicit capabilities and also the macro capabilities of Scala, we are able to let the bindable be used as a simple variable. So you can use a bindable in arithmetic expressions. You can use it as, from a syntax perspective, you can use it as a simple variable. But it has a lot of functionality in it. Very central is the functionality which we call binding, expression binding, so that you can really create declarative programs, create programs in a declarative way. We'll come back to this. But we'll go through very quickly so that you see how do we declare a bindable. We use the bind annotation, and we can use standard modifiers from Scala, like private and whatever. And we use var and val, whether it's, depending on whether it's read-only or rewrite property. And you can build your own, for Scala people, that's not too impressive to see that you can use tuples, you can compose your own data types. For Java guys, it's maybe a little bit more spectacular. But we can create a bindable, which is typically like a point on the user interface, with an operator which says, when this bindable is changing, then execute this code which you have specified in here. So you can create triggers, you can declare a variable and attach triggers to it. And anytime it changes, then you execute this trigger function. This one is a bindable, is a binding operator. So this line means I declare a variable called bindable, and this one is bound to this expression, which again might consist of a lot of bindables. And what happens then if any of those bindables change, if they get a new value, then the whole expression is recalculated and assigned to the variable bindable which is declared. So you can define your invariants. You can say this is an invariant for this bindable, this is the value definition or the value of this bindable, and it's always going to be there in the whole program if you don't change it anywhere else. So you can very declaratively define the position of a certain element of the screen, for instance, is depending on those two variables, and it will always keep that position according to the expression. Here you have a bidirectional bindable declared, which means you can here have tuples on the side, so you can say I declare a point, and anytime the point is changing, those variables are changing, those bindables are changing, and vice versa. So you can have bidirectional properties, bidirectional binding for properties. Here you can have virtual properties, like in this example you see an endpoint depends on the size of the object in two directions, depending on the expansion, the size, and the start point, in both directions. And you can have some simple synonyms, say, for some reason I want to have some shorter, be able to address this one with a shorter name, so you can define that as a. Okay, I will try to go through it quickly because it might be a little bit boring and a little bit dry to see it just like this, but it's useful to have seen it before going to the source code. Some of the basic operators you see here, which are the binding operators, like this one, is used a lot when you do declarative user interfaces. You use this one a lot. Then we have something which we call a trigger operator. This one is basically saying if the position is changing, then execute the expression on the right side. So, and if you add a star to it, then it executes it only if the property is changing, but not as you initialize the binding. Then we have what we call an imply operator, which is a bit sophisticated. This one can be used is very useful in situations where you, in this expression, do allocate some resources. Those could be disposers, for instance. Any binding has a disposer associated to it. So normally if you create programs using a lot of resources like this, you would have to clean up a lot as states are changing in the user interface and so on. This operator does it for you. So in this case, if this position is changing, then whatever was allocated inside of the expression before this change is then going to be cleaned up and reallocated. The same with this when statement. As soon as this condition is changing to true, it could be any time in the future, this expression is executed, and as soon as it becomes false again, anything in this expression which was allocated is then cleaned up or reallocated again. And the opposite if the otherwise is being used. This one is optional, of course. We also have the trigger function associated with the when conditioned syntax. But when you use this one, there is no cleanup or something like this being done. Okay, knowing this, it will be easier to understand the source code if we start looking at it. So, maybe we should go into some simple samples and look at the source code.
Which one do you want? Or should I go through the untangled planet?
Yeah, that's it. Yeah, untangle and pants.
Okay, I will start to speak too. I will show you a little program. I want to tell a little bit about the story. I can't tell the story.
Now this
Okay.
untangle was written in a hotel room during a stay which we had in Holland, some conference there. We guys were sitting in the bar in the evening, and Florian said he wanted to go to bed. So, and in the morning he said, well, he didn't just sleep. He created a small game which took him 2 hours or something in the night. So, the point is, this is a simple, very, very simple game. We call it Untangle. It will tell you what it does, but it runs everywhere, and it was written in 2 hours. That's maybe a little bit spectacular.
It also works on Android, and I don't have an iOS sample, and it also works on the web browser, but this one I can show you only later and not now at the moment. And I will open the program. A special Windows feature, opening windows at a non-existing screen.
It's hard to read, it's very small letters.
Yeah.
Yeah.
It's on the non-existent screen. Yeah. That's fine.
This is a 100-line of program, which is the entire thing, actually.
Run. Try to run. Okay. This is a program about graphs, and you have to unwrap the graph so that the corners and that none of the edges crosses each other. And maybe you know the game from some Android or iOS apps. And whenever no more edges crosses each other, you have succeeded at the level, and then a timer starts, which counts down and the next level starts. Now it finally runs, and you can see about how it works. You can track all the circles. When the lines are crossing, they become red. When they stop crossing, they become green. And when no one crosses, the next level starts, and it becomes with every level a little bit more difficult. That's basically the game. Let's go a bit through the source code. Okay. This SimpleFX app is a kind of starting point for the application. It works similar to the app of Scala. When you write such a SimpleFX app, you have to define either the window, or you can define the scene, which is a JavaFX technical term, or the root, which is the first element of the scene. And the JavaFX scene is a graph where all the visible elements are put into, and the renderer then goes every frame through the whole graph and renders each element of it.
It doesn't really look like a Scala program, does it? It's a bit different.
Yeah.
Our class, let's go quickly through the class. We have our starting point, we have some initial declarations at the top. We have two classes, corners and edges. Corners are the circles and edges are the lines, which are not allowed to cross. Then we have some statements which tell you which nodes should be put into the scene to become visible. Then we have a create level function, which isn't quite interesting for SimpleFX. It's just functional programming. And the level generator is to prove that the level is solvable. How is this done? Put some edges on the screen and then put as long corners to the level as long as the level is still solved, and then put all the circles in random positions. That's the level generator, and that's what's happening here. Okay. Then we have a line intersection algorithm, which is also not quite relevant for SimpleFX, and we have some code to start the next level. Okay, let's go up. The scene is the level which gets started when you start the program. It's 800 and 800, 800 multiplied by 800 the size, and the color is light blue. There are many names for colors defined where you can search out and find the matching color for whatever reason. Or you can define it as your RGB values. Pin is the group. The group is a JavaFX class where you can put other nodes into it. And the pin is the group where we pin other classes into it so they become visible. And random pos is a function that creates a random position at the current level. Okay. Here we define some binables. Binables work like variables in Scala, so they are kind of syntactically compatible 100%, but they allow you to do additional operations, which you will see soon. We have a binary for the level, we have a binary for the next level counter, we have a binary for finished, we have a list with all corners and a list with all edges. The finished, all sys variables except finished are declared with a starting value, but the finished variable is a little bit different. The finished variable is defined by a binding. How is finished defined? All edges shouldn't have any collisions. So this is defined by this declaration. When now one edge becomes a collision, the whole expression gets re-evaluated and the finished variable gets updated. So I don't have to manually, for example, look every frame through all corners and update the finished variable, or the other way would be whenever the position of a corner changed, update the finished variables, and you write your listener by hand. No, you just write the binding once. You have to think, I have to find an expression which tells you if the level is finished, and when I've found this expression, I don't have to care about the update logic when I have to check it. I just bind it to it, and whenever a variable or a bindable changes, it gets updated automatically. This way I have to think much less about how to write the correct program. I make less workarounds like putting change listeners to every variable in the hopes that now I have found every case which is possible, which you can probably find in a lot of GUI code, especially with Swing or also normal JavaFX code. I will speak, it's a whole presentation. I will mainly speak about this binding because that's the main concept in my opinion. We skip the class corner and go back to it later and go to the class edge. Edge are the little lines between the circles. It has a declaration for the hash collisions. It has a start point, it has an end point, it has a stroke. This is where we could also rename stroke color, so it would be more specifics. So one would better understand what it does. It has a stroke width, which is always constant. And when we create a new edge, we put it to the binary edges. So the list gets updated, and every binding which uses the list of all edges gets updated too, because the edges was a binary. So this is quite handy. The edge, when we create the edge, it gets two corners, and one is the start corner and one is the end corner. We have to update the start and end position of the line, and how do we do it? The line has a start bindable, and we bind it to the position of the start corner. And now it gets updated whenever the start corner changes. We do the same for the end position of the line. Whenever the position of the end corner changes, the end position changes. What's a little bit interesting here is that you mentally don't have to think about changes, but you just say this variable should be always be defined by this expression. You kind of change by defining something in a really declarative way. And the stroke binding is a little bit more different, a little bit more interesting than the start and end binding, because it contains of a more complex expression. The stroke binding is if has collision, color red, else color green. This reads quite logical, so there's nothing else to say. And whenever the hash collision changes, the color changes too. Any questions so far? No? Silence?
Can you read it? Or are the letters?
Yes.
When no one asks a question, then I will have to continue.
Better ask a question.
Okay. Okay. Let's go to the scene graph, and at this part we build up the whole scene graph. We tell the program what should be rendered. What should be rendered? At first we should render all edges, so we create a group and put all edges inside it. The children of the group is bounded to the binary edges we have declared earlier, and whenever we create a new edge, the new edge gets inserted into the edges variable. Then we add all the corners to the group. Then we add a label which tells us the level counter, because whenever we finish the levels, the counter goes up by 1, and the text gets updated automatically. So it's a code where we say go to the next level, we don't have to care about the string of the level counter, because the level counter is already bounded to the level number we have. So it's a next level place, we only have to increase the level counter, and the rest is updated automatically. This makes refactoring the code a little bit simpler, because you don't have to group the parts of the code together, and you also don't have to do the throw everything away and create everything new pattern, which is also quite common in the GUI programs. Maybe you have wondered a little bit how one can program user inputs this way, because this looks quite useful when you have some data, but how to process user input. There's one case where this is quite elegant. We have the drag and drop functionality. I want to show it shortly before going to the place that is defined. I mean, it's quite simple. I have my mouse. When I click down, the position of the circle should change the same way like the position of the mouse cursor changes. Okay, maybe we can write this down in an elegant way. And this is the corner, and this is the definition of the dragging functionality. What do we write? We want to define how the position of the circle changes. So we write delta center. Delta is, well, a little bit familiar from Mars, but it should be quite readable. It has some meaning which makes sense here. We just define the change of the position. Now, okay, what should the change of the definition be? It should be the change of a variable which defines the whole distance we have dragged until now. We have a variable named drag distance. When you drag the object, it changes by the distance you drag, and this change will be put into the position, the change of the circle. Any questions? Questions now?
Maybe could you show the definition of the drag distance? Where does it come from?
Yes.
From the circle?
No, it's for every node. I just have to switch the.
Yeah, it's from the circle, but it's
Okay.
but it's from the super.
So the drag and drop functionality is like embedded in the superclasses.
Yeah.
Okay. Is it really a distance? Isn't it like a vector? It has like. What is the type of the distance?
Yeah, it's a pair. Yeah.
Yes.
It's a double to. Okay, in this sense, it's
Maybe the name distance is not precise.
Yeah, mathematically, it's alright. Yeah.
That's an argument.
It's a tuple though.
Yeah.
It's a good question how the drag distance is defined, because it also fits well to the bindings, because it's like I said previously, it's a distance, the drag distance. How is it defined? It is 0 at the beginning, and then when the mouse button is down, it's the change of the mouse position, and when the mouse button is not down, then the change is 0. Maybe I will show you later.
Yeah.
You can
I
go to
think
the
this-
planet simulator.
Yes.
If you go to this one.
I think but the nice fact is that the track distance is able to define in this elegant way. It's like a one-liner. I think it is a one-liner. Okay. Any more questions?
I think, for me, it's slightly difficult to grasp it because I'm not coming from this like a JavaFX world. So I think what might be interesting if you can show some a code in JavaFX and how you made it in ScalaFX. Because what's the simplification and what's the because now it's difficult to slightly to see the advantage of shorten from 45 pages to 10. But it would be nice to see face to face, how it looked before and how it looks now.
Yes.
Now. Because I don't know, for me, it's kind of difficult to figure out because I'm not, familiar with this kind of UI stuff. So as you work with it every day, for you some things are kind of coming as defaults. But
Well, I'm rarely seeing normally our code.
have you got some examples where you can
Yes.
show some how it looked before in JavaFX and how it looks in SimpleFX?
We could. Do you have the source code of the web browser? Or the Java source code?
No. No.
And the Zen guitar. The problem is we are not big fans of Java. Okay.
Yeah.
So
but
we don't work with that.
yeah, but I
But
think
we have some around.
because
Weren't those the old examples?
Yeah, we have. Yes, we have. But
I've got them
I
on
think
my,
that
I've got them on my laptop.
you have. I have one. I think I also have one.
But I expect the JavaFX is similar to Swing,
Yeah,
even listeners.
it's better than Swing though. It's 10 years at least
Yes.
younger,
Yeah.
so it must be better, right? So the Java desktop community is migrating from Swing to JavaFX.
And is JavaFX declarative? At
No.
least.
No, it's not.
So that's the big difference.
It's a matter of definition.
And the JavaFX has, they were propagating the binding features a lot, and they have a binding, they have a lot of binding functions in there. They have a special package in their project which they call binding. Okay, but it's very simple. So we don't use the binding from JavaFX at all. So we wrap it and people can use it, but we have our own binding implemented. And the same with the properties. We don't use the JavaFX properties. No, they are using the setters and spread them around. We are propagating also this kind of JSON style, here where we say we don't think it makes sense to instantiate an object and then you spread your setters around in your source code. If you read it, you can never know if somebody is making a new circle somewhere. And in the Java code, you can never know whether 100 lines later he is setting a property of this object. Here we propagate that when you instantiate a circle, you immediately define the attributes for it. And if those attributes don't have a constant value, they might have some values depending on other properties, right? Then we declare this in a binding structure. You declare the invariants. And of course you have triggers, you can have typically mouse events, which change it. Okay, then we use these arrows in the other direction, which can very easily read. And they're also easy to read, they're eye catchers. But we have some Java code which we have translated. So it's a matter of getting it on the screen now.
I'm asking because I think the biggest audience or group of interest would be coming from like a JavaFX world, you know. We can hardly anticipate that like the backend guys would start like writing this UI thing. So I'm just like because I don't know when the guys like a Spring wrote Spring, they so like this is J2E and this is Spring, you know. So they could drag the attention why it's simple, why it's better, you know. It's just for me it's difficult to see the advantages of it. You know. It's in Scala, but you know, if you show me like this was before and now it's like this, not just in lines, but even the kind of code itself.
Yeah, but here it's kind of weird, so maybe it doesn't work. Okay, so let's go back to here, which there's a browser drag drop from there, there's the audio, so we can start off with this one. So we got low or
Don't know this comparisons.
okay, so we've got the drag, so here's the easy effects, or here's the Java effects hello, and Java web view, or the easy effects web view.
The Java web view is good. It's a good example.
Okay.
Yeah.
That one, and then we do that one.
Maybe that's a little kind of thing.
Those are PDFs, you can just open.
Vielleicht soll ich erstmal ein Planeten machen und das danach machen.
Okay, so.
Když budete hodně
This is
prosit, tak
Scala version. Okay.
když budete hodně
Yeah, we
prosit,
can go
tak
through
ano.
the Scala version.
Okay, so.
No, it's
Yeah,
let's go to the Java. You have the Java there.
that's the Java.
Yeah, let's take a look at this. This is JavaFX. There is a package with some classes to deal with the HTML content, the HTML and JavaScript content. So you basically can embed your own browser into your JavaFX code. So it has basically just one limit, which is it doesn't take any plugins. So you can't run Flash or anything in there. But except from that, it renders HTML5, JavaScript very well. So, and those are easy classes to use. And in this sample, this is a piece of source Java code taken from the Oracle sample page, the tutorial basically in the internet. So we can scroll down a little bit and look at this code.
The magic word of import.
Yeah. So you might recognize kind of scenes that Florian was using in his sample as well. You need a scene which is the container basically for the UI. In the scene you have a so-called scene graph, which is a graph structure of nodes, it's a tree structure of nodes, which starts with the root, which is basically the JBrowser in this case. Yeah, you can set CSS, it is fully CSS compliant as well. So this is the main class, which extends the application, and it goes into this JBrowser, which is the major application. And I think that comes on here. You have the JBrowser.
You don't have by any chance like the source code of the guitar in JavaFX and your
Yeah, we have apps from the Java. We have the guitar also, yeah? You
Yes.
must have it.
Yes, I have it.
I may have it here, I've got the audio code, is that the same thing?
Yeah, that's another one, yeah.
So do you want to see the?
Yeah, just go to, because the others are a little bit longer. The audio code, which you mentioned, is 30 pages, and the Zen guitar is 12, 13 pages, I think. When not more. So it's in Java. So, but if this is not a Scala, we should. Should we take a look at the Java code?
I think it's okay. I think it will make sense to compare like the same codes. You know, if this is something else, it doesn't give the overview how we made it simple. Or this is something else, so I can different code, different.
We can do it maybe after the presentation more
Mm.
because you need to screen more
Yes.
longer files.
Well, here's the easy effects for the browser.
Yeah, but we can do it afterwards.
Yes, I think better. This would be too. I'm not yet finished, so.
Switch to the Planet Simulator now.
Yes. What's some effect when you translate JavaFX code to SimpleFX? You often have some kind of spaghetti code, you have some different methods, and you kind of find out, and here gets this variable operated, and here, and here. And after a while, you find out, okay, this can be expressed with a one-line binding.
Yeah, I'm not saying like it's easier, it's just like it would help to understand
Yes.
the simplifications, because
Definitely.
I don't know the JavaFX, so I saw like two or three applications
Yeah.
when it started, and then
Yes.
I did for years. So
I think a little problem is that I don't like looking at JavaFX code, so
Java code in general.
yeah. Okay.
Machen wir schneller durch.
Okay, back to the unhanger. We have now this dragon defined with our deltas. What do you think when we have deltas? Maybe I could write some programs where I associate a little bit more with delta. Maybe a physics simulation, a small one. Maybe with something with some differential equations. It should be possible. For example, when we write a physics simulation, we often have to differentiate by the time. So what do we need to differentiate by the time? We would need a delta time. Then we could do it without any problem. We have defined time as a kind of global bindable which gets updated every frame, and with this bindable I can write my differential equations. So we had some fun and wrote a physics simulation, a planet simulator, which is a simulation of a small star system. With, I think in this case, 100 planets, and each planet has a gravitation to each other planet. It is controlled by one sun, which has more mass than the other planets, and the rest flies around, and by the time it becomes more and more chaotic. It also has some nice tracking and zooming functionalities. And I should remove this. And by the way, it's a 100 lines of code program. This is part of the...
And exactly the same code runs, basically anywhere.
So you can do like 3D graphics engine in JavaFX or the SimpleFX?
JavaFX comes with a 3D engine.
And when you compare, for instance, OpenGL stuff, how does it like
The 3D features are not comparable to OpenGL and to WebGL and so on.
As
But it's still powerful.
And as regards to code, like, have you got some experience with OpenGL, like coding, comparing to SimpleFX?
We have just tested out a little bit. Yeah. We played around some fishes, There was a very cool WebGL sample out there, which for some reason was taken away. I don't know why. Which played with some fishes. And we made that into to SimpleFX, parts of it, and played with it. But to be honest, today the JavaFX 3D is not comparable with it.
Let's go back to the deltas. This is the whole class. It's 100 lines. It has also this initialization and dragging and zooming and rotating functionality. This is kind of the core of the program, this part, because that's where all the magic happens, where the simulation runs. How are our planets defined? They have a mass, they have a speed, and they have a force. And for utility, we have also defined a list with all the other planets. So, how do we define it? The change of our position is the speed multiplied with the change of time. Sounds correct. Let's go on. The delta of speed is the force multiplied by delta time divided by mass. Also correct. And the force, how is force defined? Okay, now that's the part where you have to remember some equations from physics. It's the sum of some equation of all the other planets. It's defined by directions. It's the direction between this planet and the other planet, the force. And the amount is defined by an equation. It's g multiplied by mass multiplied by the other mass divided by the distance to the other in the square. And that's basically the program of the planet simulator. Any question about it? Don't know how many time we have, but I could also tell something about some things like memory semantics of the bindings. What happens when there are errors, or the semantics. Maybe a little bit about the memory semantics, because I think it's quite important to understand that it's well usable. When you put a listener to an object, you have the problem that this object now refers as a reference to the listener. This can be, in some cases, unwanted. Let's make a sample with an object A. And an object B. And let's give them both a binary. There's some kind of IntelliShape bug which doesn't allow me to write add symbols, which is quite annoying. One binary. What we now do is that we bind A to B. Now the following happens. When we bind A to B, we have to make a change listener on B, which gets executed whenever B changes. Normally we would assume when B has a change listener, which has to change A, that the change listener has to refer to A, and so whenever B is referenced, always A is referenced. But in this case, it's not really what we want, because when the whole A object isn't referenced anymore, there's no need for the change listener, and also no need for the whole A object. At SimpleFX there happens some big reference magic to assure that when A isn't referenced anymore, the listener from B can be cleaned up. So it keeps the semantics you would have when you would use a normal equals operator instead of a binding, because when you write A is equals B, there will be no reference from B to A. And the binding behaves the same way at the semantic level. Okay, now questions?
Is this driving to Berlin?